Hi everyone, my name is Nguyen and I'm from a group of three members, Viet, Quan, and me. Today we would like to talk to you about diabetes prediction using decision tree. Our presentation is divided into five parts. I will start with why we choose this topic, the application, and the technologies we use. Next, we will cover the entire software operation process and finally the additional feature. So now let's move to the first part of our presentation, which is about reason for choosing the project. Public health impact. Of course, diabetes is a global health issue affecting millions and leading to serious complications if untreated. For example, according to statistics from the International Diabetes Federation (IDF), in 2021, an estimated 537 million adults worldwide were living with diabetes. It was also responsible for 6.7 million deaths in 2021. You can look at the pie chart below for more intuitive visualization. By focusing on diabetes prediction, this project aims to contribute to healthcare effort by helping identify individuals at risk before symptoms become severe. Interpretable model choice. Decision tree offers a transparent approach that is easy to interpret, making the prediction process understandable for healthcare professionals and stakeholders. Another significant point is hands-on learning. This project provides hands-on experience with decision tree, a popular machine learning algorithm, and builds skill in data pre-processing, feature selection, and model evaluation. Use metric to classify and evaluate models, ensure that the model performs well not only on training data but also on unknown data. So now we move on to the next session, which is real-life application. The first, early screening and diagnosis. Decision tree models can assist healthcare providers in quickly identifying individuals at higher risk of diabetes. This early detection enables timely intervention, reducing the likelihood of complication and improving patient outcome. In the era of scientific and technological development, remote health monitoring is very popular. This model can be embedded into mobile apps and digital health platforms, providing users with accessible risk assessment based on their self-report. This empowers individuals to monitor their health and seek medical advice when necessary proactively. So our third part covers the technologies we use in the project. About programming language, Python was chosen for its simplicity and extensive library support, making it ideal for data processing, machine learning, and backend functionality. JavaScript is used in conjunction with React to build dynamic, responsive user interface, enhancing the accessibility and usability of the project. In addition, we also use several core libraries to streamline the model development and deployment process. sklearn enable efficient decision tree training and evaluation. Pandas and NumPy support data pre-processing and numerical computation, while Matplotlib library provide data visualization, and many more libraries help us execute the project smoothly and efficiently. About datasets, the dataset used in this project is a PIMA Indian diabetes dataset, contain key health metrics like age, BMI, glucose level, and blood pressure, with many instant and binary labels indicating diabetes risk. It serves as a reliable foundation for training and testing the decision tree model. So that's all I have to say about why we choose this project, its application, and the technologies we use. Our next part will cover the entire software operation process presented by Quan. Okay, Quan, please.
Hello, teachers. So now we'll move on to the building model process. We'll have three phases. First, we will load data, libraries, and read input data sets. Then we'll have our first training of the model. Then we'll look for the results and refine our model to find the best accuracy. First thing we need to do is to load data. And we'll import our data set and set the corresponding column names. Then we need to sort throughout our data to make sure that does not exist any unknown values or outliers. And we also have to clean our data, as in our data set, there are slots that contain value 0. We will remove the rows that have zeros for the instance that will not dramatically decrease our sample size. Okay, now we have cleaned our data set from most missing values, and we'll begin to construct our decision tree. We'll split the data frame into columns used for classification and our parameter of interest labeled as the class variable in our current data frame. We need to divide our data into training and training sets. Then we use scikit-learn decision tree classifier library to build a decision tree model. And instead of using the default G9 criterion, we use the entropy criterion to measure information gain. We're not going to specify any other parameters for now, as we'll use other techniques to fine-tune the model later. In our first training, we created two test sets. The first one labeled X test and Y test will be used at the end of the model with the five-fold validation. The second one, which is a subset of our training data, labeled X fake test and Y fake test, will be used to test the initial decision trees and the pruning steps. And for the results, as you can see, the decision tree is very huge, which leads to overfitting and decrease the accuracy. Then we will plot a confusion matrix to see how our tree would respond to the training test set. And now my friend Viet will demonstrate the result of this first training.
Okay, so hello, teacher. As you can see in the previous slide that Quan had mentioned, we have the problem here, which is our initial decision trees models fell short of expectations. The models was overfitting the training data, leading to the poor generalizations, and we have to improve the model accuracies and robustness. Okay, so here what we're gonna do in this, we will introduce the cost complexity pruning. This is a technique to simplify the decision trees. We have to prevent overfitting by reducing the tree's complexity. And how it's gonna work? It will create a sequence of subtrees with decreasing complexity, and it use a cost complexity parameter alpha to balance accuracy and complexity. So in detail, we will use the subtree from scikit-learn library to find the optimal trees. We will ignore the highest value of CCP alpha parameter, as it would result in a single root node. We are going to plot the decision trees with maximum mean value from the five-fold validations, and then we use five-fold cross validation to run through every single alpha and really find what value is gonna work best. Okay, so in here we have defined an pruning functions. As you can see, this short cut of our code. We create the for loop in alpha, and then define the decision tree classifier here, and then return the CCP alpha. And then it's also important to store all the calculated score to an array to store all the decision tree from each combinations of prune leaf from the original trees. And the result that we attain, as you can see in the slide here, the accuracies here is reached up to 76%. And also the data we had of run through our code to plot our tree, and also confusion metric here is we have reached the optimal decision trees through our improved code from library scikit-learn. And also result of all the value necessary here, more details when we run the model, such as the best alpha for the model, accuracy, confusion metric, and some validation score. And also we have developed additional feature, which is we bring it into the interface so user can input their health indicator such as glucose, insulin, BMI to predict their diabetes risk with 76% of accuracy. So let's see. First, in the interface here, in this we have used the UCI diabetes dataset to train the models, and as you can see in the slide here, the first picture is a initial startup interface, and then when we import the data and then analyze this, we will display the result of the model metric such as accuracy, confusion metrics, and some future important, as well as the cross-validation score and the best alpha. And after training the best model, user from the dataset, user inputs, the model will save into files. Here, it will save in this file in the second figure here, models, and then user can input their data from the data set that they import into the interface, and then predicts the result will display here with the result contain predictions, O for the negative, 1 for the positive, along with the associated risk probability. So in here we have the video of demo. What we gonna do, we import the data and wait for the training process. It's take a bit of time because the training process will calculate. It is expensive calculations, and after some times we have result here, and also we have to test some input that we have trained from the previous models. So let's see. You have to fill out the health indicator such as pregnancies, glucose, blood pressure, age, and we test their own of the trained data set here, and also it's display the same result, which is 0, which mean negative, and with the low risk of diabetes. And let's test some positive one, the first line. And we predicts, and the result is to display 1, which is also match with the data set 1 in the our trained data set. Okay, so it's next slide please. So in the conclusions, we have successfully trained diabetes prediction models with a reasonable accuracy of 76%. This also avoiding of overfitting, and this model can aid in early detections and provide valuable support for healthcare professionals in improving patient outcome. So this is the end of our presentations. Thank you for listening.